Hey everybody, so today we're going to talk about section 3.3, which is the beginning of graphing parabolas. Okay, so the first thing we want to do is talk about our first method for graphing. Okay, so we're going to use base graphs. So a base graph is the graph of the simplest example of a type of function. Okay, and the point of a base graph is that it will give the shape of the graph. Okay, so for example, y equals x squared, okay, is the base graph for quadratic functions. Okay, so for x squared types of functions, the most basic one is just y equals x squared, okay, and this will give us the base graph. Okay, so to explore what the graph looks like, we're actually going to do this worksheet here, and you can find this linked on Canvas. Okay, so the first thing we're going to do is just fill in this xy table for these different functions, okay, and then we're going to graph them all, okay. So if I was you, I would pause now so that you can fill these all in, okay. So -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. Okay, and then I'm going to do the same thing for all of these different, oh, and then I'm going to graph that one, I lied. I'm going to take a break and just graph this, okay. So I have the point -2, 4, okay. Then I have the point -1, 1, 0, 0, 1, 1, okay, and 2, 4. Okay, and I'm going to connect these with a smooth shape. Okay. Okay, you can see what this graph looks like. This is our base graph. Okay, and let's talk about what this is called. Okay. The shape of a quadratic graph okay, is called a parabola. Okay, so that U shape that we saw is called a parabola. Okay, and for our purposes, when we're talking about for y equals x squared, okay, so we're going to use 3 main points to graph. Okay, and those points are called key points. Okay. So when we're using our base graph in order to make our graph, we're going to use 3 key points. Okay, these are going to be -1, 1, 0, 0, and +1, 1. Okay, so you can see on our graph, okay, that's these 3 points here. Okay, and when we draw the other graph, we'll look at how those points change. Okay. The other thing that I wanted to say is there's an important point on this graph. It's right here. Okay. And that has a name also. Okay, the center of this parabola is a point called the vertex. Okay, so we can see on our base graph y equals x squared, we would say that the vertex is the origin 0, 0. Okay, so we have that on our base graph, our 3 key points are here. Okay, and this center point is especially important. It's called the vertex. Okay, all right, so let's look at how the rest of these are going to work. Okay, so I'm just going to plug in values for x. Okay, so negative 2 squared is 4 times 1/2 is 2. Okay, negative 1 squared is 1 times 1/2 is 1/2. Okay, 0 squared is 0 times 1/2 is still 0. Okay, and 1 squared is 1 times 1/2 is 1/2. 2 squared is 4 times 1/2 is 2. Okay, so now I'm going to graph this parabola. Okay, so I have negative 2, 2. Okay, then I have negative 1, 1/2. I have 0, 0. Okay, I have 1, 1/2, and I have 2, 2. Okay, so now I'm going to graph this. Okay. All right, and then I'm going to proceed to do the same thing for these other two. Okay, so I have y equals 2x squared. Okay, so negative 2 squared is 4 times 2 is 8. Negative 1 squared is 1 times 2 is 2. 0 squared is 0 times 2 is 0. Okay. 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. Okay. All right, so now I'm going to graph all of these points. So I have negative 2, 8. 2, 3, 4, 5, 6, 7, 8. Okay. Then I have negative 1, 2. I still have 0, 0. Okay, then I have 1, 2, and 2, 8. Okay. All right. And then the last one I'm going to do is the last one over here. Okay. So negative 2 squared is 4 times a negative is negative 4. Negative 1 squared is 1 times negative 1 is negative 1. 0 squared is 0. With a negative is still 0. Then we'll get negative 1 and negative 4. Okay, so I'm just plugging in these same values for x. Okay, so I have negative 2, negative 4. Okay, negative 1, negative 1. 0, 0. 1, 1. 1, negative 1, sorry, and then 2, negative 4. Okay. All right, so there's my 4 graphs. Okay, and then remember we're going to compare them to the equations here. Okay. All right, so let's answer these questions. Okay, so it says, what are the similarities in the graphs? Okay, so one thing that I would say is they're all the same shape. Okay, so they're all parabolas. Okay, and this is important, right? These all have the same base shape because they're all x squared types of graphs, right? All x squareds are going to be parabolas, so it's important to think about that as a similarity. Okay, If we look at them, the other thing that stands out to me as being similar is they all share this 0.00, okay? So they all have the same vertex, okay, which is 0, 0. Okay. All right, let's look at some differences, okay? So I think the most obvious difference when you look at this is that the last one is upside down, okay? So let's look at why that might be upside down, okay? We'll think about that later, okay? But we're gonna say that the fourth one is upside down. Okay, that's important. That's a difference, like a very obvious difference. Okay, and these other ones, it looks like they're all different widths. Okay, some are skinnier and some are wider. Okay, than the base graph, which is the one in black. Okay, and then the last question is, what conclusions can you draw about how the equation affects the graph? Okay, so first we're going to focus on this here where it says the fourth one is upside down, which is the green one, okay, this last one. Okay, so when we're comparing the equations, right, we're looking for something different that would make this last one be upside down. Okay, so I hope you can tell that it's the only one with the negative sign. Okay, so what we're going to conclude is that the negative sign reflects the graph, right? Meaning it flips it over. Okay. And then we're going to think about what's causing these different widths. So we're going to compare the first three, right? This one has a coefficient of 1, and you can see here it's this standard width. Okay. This one has a coefficient of 1/2. You can see that that one is wider. Okay. And this one with the coefficient of 2, okay, that's going to make it taller and thinner. Okay. So we would say that a larger coefficient, okay, means taller, okay, and a smaller coefficient, right, it's taller and thinner, and the small coefficient, like 1/2, is going to make it wider or shorter. Okay. All right. So let's talk about that more specifically. Okay. So we are going to look at what we call transformations. Okay. And these are just changes from the base graph. Okay. So if we have something that looks like this, okay, so we know that if A is negative, okay, the graph is reflected to be upside down. Okay, so that's one transformation that we saw in the previous example. Okay, now I'm going to give you some extra information from what we saw in the previous example. We knew that this number affects the height of the graph, okay? So we would say the height, okay, which is the y coordinates, are multiplied by a, okay? So let's look at what I mean by that, okay? So for the first example, we have that this number is 1/2, okay? So we're looking at these y coordinates, and these ones are half of the original ones, okay? So if you look at the graph, for the same x value, the y value is half as large, and the same here. For the x value, the y value is half as large. You can see that for these two as well, okay? Now for this one, the y value should be twice as much as the original. So 4 times 2 is 8, 1 times 2 is 2, 0 times 2 is 0, 1 times 2 is 2, 4 times 2 is 8. So you can see that these y values are double the original ones, and it's because of this 2. Okay, so when you look at the height of those points, for the same x values, they're twice as high. Okay. All right. So that's what we're going to see from the coefficients here, right? The coefficient of x squared. Here's the normal one. We can see that this changes them to 1/2 their original height. This changes them to double their original height. And this flips the graph upside down. Okay, let's look at a different kind of transformation. Okay, so I'm going to start by filling in the values again for my normal graph. So these are going to be 4, 1, 0, 1, 4. Okay, we had that on the opposite side. Okay, then I'm going to fill in this one. Okay, so -2 squared is 4, plus 4 is 8. Okay, -1 squared is 1, plus 4 is 5. Okay, 0 squared is 0, plus 4 is 4. Okay. 1 squared is 1, plus 4 is 5. 2 squared is 4, plus 4 is 8. Okay, so let's really quickly draw our base graph here. Okay, so we have the 0, 0, -1, 1, and 1, 1. Okay, and then we had the -2, 4, and the 2, 4. Okay, oops, this is 2, 4. Okay, so we're going to draw in our base graph again so that we have something to compare to. Okay, we're comparing all of our graphs to the base graph because this is the normal shape, okay, the base shape. All right, so then for the next one, okay, we're going to graph these points. So we'll have -2, 8. Okay, so -2, 8. Then I'll have -1, 5. 2, 3, 4, 5. Okay, 0, 4. Okay, 1, 5, and 2, 8. Okay. All right, and then we're going to look at this last one, okay? So we would have -2 squared is 4, minus 3 is 1. -1 squared is 1, minus 3 is -2. 0 squared is 0, minus 3 is -3. Okay. 1 squared is 1, minus 3 is -2. And 2 squared is 4, minus 3 is 1. Okay, so now I'm going to plot all of those points. So I have -2, 1. Okay, I have -1, -2. I have 0, -3. Okay, 1, -2, and 2, 1. Okay. Okay, so there's all of those points. Okay, so you can see how they're similar and different. So let's answer these questions about similarities and differences. Okay, so what are the similarities of the graphs? So again, we can see that they are all the same shape. Okay, they're all the parabola shape, right, which is indicative of the x squared. Okay, in this one, I think it's important, especially because last time we talked about the width, to say that these are all the same width. Okay, these are all exactly the same in terms of width, and we can say they're all pointed up. Okay, so these last two are in contrast to what we saw in the previous example where they had one that was pointed down. This time they're all pointed up. Okay, and last time they all had all different widths, but now they all have the same width. Okay, now if we want to see why that is, remember the width is dictated by what's in front of x squared. They all have 1 in front of x squared, so they should all be the same width as the base graph. Okay. Also, we know that the minus sign in front of x squared flips the graph, and these all have positive x squared, so we know that they're all going to be pointed up. Okay, so what are the differences here? Okay, so I would say they all have different vertices, right? Right, you can see the vertex of each graph is different. Okay. And that's really the only difference between them, right? These are all exactly the same, except they're shifted up and down. Okay. Okay, so let's look at what might be shifting them up and down. Okay, so if you look at this graph, the only difference to the blue graph is that it looks like it's shifted up 1, 2, 3, 4, right? If you go up 1, 2, 3, 4, right? 1, 2, 3, 4. You can see that these key points that we have marked are shifted up 4. So when we look at the equation, we can see that this plus 4 is probably what's moving the graph up 4, okay? So we would say that when we have the plus 4, okay, we can say that that's probably moving my graph up, okay? Now between the base graph and the pink one, we can see that the pink one is shifted down, right? How much down? 1, 2, 3. Okay, so let's look at the equation. Well, here's this minus 3. So we're going to think that this is probably moving the graph down. Okay. All right, so let's be a little bit more precise and add this to our list of transformations. Okay, so if we're talking about y equals x squared, okay, plus k, okay, so we would say that if k is positive, okay, the graph moves up k. Okay. Now, if we have that k is negative, right, like the previous one, then we would say that the graph moves down k. Okay, so adding or subtracting a number out here changes the graph, right? So adding something will move it up, subtracting something will move it down. Okay, so we are going to use that information, okay, to make a graph ourselves. Okay, so this is going to be our example where we are creating the graph. Okay, all right. So I want you to see the directions that I will normally use for these types of examples. So we're going to graph using base graphs and transformations. Okay. All right. So let's look at some examples of this. Okay. So the first thing I want to do, right, is think about my base graph, which I know looks like this, right? Okay, and there's my 3 key points. Okay, so here's my base graph. It has this parabola shape, right, the U shape, and here's my 3 key points, right, that we talked about at the beginning. Okay, now I'm going to say, what is this -2 going to do to the graph? Okay, well, we said that when we have a minus out here, this is going to move the graph down 2. Okay, so we're going to look at our graph here. Okay, so first I'm just going to draw the base graph for you guys. Okay, with my key points marked. Okay, so this is the base graph. Okay, and then that's just for reference so that we don't have to turn the page. Okay, so now what I'm going to do for my graph, right, is I said everything should be moved down 2. So I'm going to take each of my 3 key points and I'm going to move them down 2. Okay, so I'm going to take here and I'm going to go down 1, 2. Okay, so it was here, I'm moving it down 1, 2. Okay, my vertex is going to move down 2, so it used to be here, move it down 1, 2. Okay, and then my last key point that used to be here, I'm going to move it down 1, 2. Okay, so there's my 3 key points, and then I'm going to draw in the base graph shape because I know it is parabola shaped. Okay, and there's my graph. Okay, just as easy as that. All right. So let's look at another example of this. Okay. Okay. So I'm looking at y equals 3x squared. Okay, so I know what my base graph looks like. I know what y equals x squared looks like. Okay, now what is this 3 going to do to the graph? Okay, so this is going to multiply the y coordinates by 3. Okay, so what I mean by that is I have this point in my base graph. Okay, so when I look at my new graph, the x coordinate will be exactly the same, and the y coordinate will be times 3. So 1 times 3 is 3. Okay, and I'm going to do that for each one of my points. So I had 0, 0, and also 1, 1. Okay, so in the new graph, the x coordinate is exactly the same, and then the y coordinate gets multiplied by 3. So 0 times 3 is 0. Okay. Here, 1 times 3, right? X coordinate is the same. Y coordinate times 3. So 1 times 3 is 3. Okay. So let's look at a graph. Okay, so this is going to be for part B. Okay, and then I'm going to graph those 3 points that I just found. So I had -1, 3. So -1, 3. I had 0, 0. And I had 1, 3. Okay, so once I've marked my 3 key points, then I just graph the base graph shape. Okay, now you can see when you compare this to the base graph that it is taller and thinner, just like we know about those multiples. Okay, all right. So let's look at some examples where we have more than one change to the graph. Okay, so when we look at this, right, we know we have the base graph, okay? So this 2 is going to multiply the y coordinates by 2. Okay, and then this minus sign is going to flip it upside down. Okay, so let's look at what our graph would look like. Okay, so I'm going to start with my key point here. Okay, so it's at 1, 1. Okay, I'm going to multiply the y coordinate by 2. So 1 times 2 is 2. Okay, then I'm going to flip this upside down. So I flip it from here to here. Okay, you're reflecting it across this line like a mirror, right? So you're mirroring this image from being up here to being down here. Okay, now the point at 0, 0, okay, I would multiply the y coordinate by 2, so 0 times 2 is 0, okay, and then I would flip it. Well, it's on the line that you're flipping it across, so it doesn't move. Okay, now my last point, it's right here, so I'm going to multiply the y coordinate by 2. 1 times 2 is 2. And then I'm going to flip it upside down, so I'm going to flip it down here. Okay, and then I'm going to connect it with the shape of the base graph. Okay, now I know it's flipped upside down, so I'm definitely drawing the base graph upside down. Okay, so this is the method. We draw our 3 key points and then we connect it with the parabola shape. Okay. So let's do one last example where we have 2 different transformations. Okay, all right. So the 2 transformations that we see here are the multiply. So this is going to multiply the y coordinates by 2. Okay, and then we know that the plus 1 is going to move it up 1. Okay, it is important what order you do these in, and you do them in order of operation. Times first and then add. So this one goes first and this one goes second. Okay, so let's look at our graph. Okay, so we're going to start with our old key point, which is here at -1, 1. Okay, we're going to times the y coordinate by 2. So 1 times 2 is 2. Okay, and then we're going to move our key point up 1. Okay, so we're going to start with our key point at 0. We're going to times it by 2. 0 times 2 is 0. Then we're going to move it up 1. Okay, we're going to start with our point here at 1, 1. The x coordinate doesn't change at all. The y coordinate gets times by 2. 1 times 2 is 2. And then we move it up 1. Okay, and then I'm going to connect it. Okay. So you can see that it's all shifted up 1, right? That's coming from this plus 1. Okay. But you can also see that here the vertical distance between these points is 2 now instead of 1 like it is in the base graph, right? So in the base graph, the vertical distance between these 2 is 1, okay? And because of that stretch, the vertical distance is 2 now, okay? All right, so we are going to graph like this a lot with a lot of different base graphs. So if you're thinking that this seems like an odd way to graph, I encourage you to practice it, get used to it, because we will be doing it a lot. Okay? All right. So let's look at something else that can help us graph. Okay. So we have lots of different ways to write out quadratic equations. Okay. So I want to remind you, okay, before we do this even, of the other forms. Okay. So when we have ax squared plus bx plus c, okay, remember this is called standard form. Okay. We've been talking about that a lot. Now, if you have this form, okay, because you've factored this, this is often called the factored form. Okay. And now we're going to learn about another format that's useful for this, okay? And it's called vertex form. Okay, so in this form, HK is the vertex. Okay. All right. And then this number A tells us about y coordinate stretching. Okay. Is there any, for example? Okay, and what is it? And the other thing it tells us about is it flipped? Okay. All right. So let's use the vertex form to graph a little bit. Okay. So I'm going to let the directions just say graph, okay? If you have something in vertex form, this is really the best way to graph, so I don't really need to give more direction than that, okay? Okay, so the first thing we're going to do is look at this that's in vertex form, and we're going to say what the vertex is. Okay, so we can see that we have -1. That means that the x part of the vertex is 1. Okay, and here's the y part of the vertex. It is 2. Okay, so the x part has the opposite sign, but the y part has the same sign. Okay, and then since the number in the front is 1, okay, there are no changes, right? It's everything else is like the base graph. Okay, so let's look at this graph. Okay. Okay, so I'm going to graph my vertex. Remember, the vertex is at 1, 2. Okay, so 1, 2. Okay, so this is my vertex. Okay, and the other key points, okay, think about the base graph. In the key points on the base graph, okay, they're arranged like this, right? Where they're 1 unit apart this way and 1 unit apart this way. Okay, so we're going to arrange the key points exactly the same. Okay, so 1 and 1. Okay, and this one is going to be -1 and 1. Okay, and then I'm going to draw in my base graph shape, the parabola. Okay, so here's my vertex at 1, 2. Okay, and then my key points are both 1 unit away in either direction in x and up 1. Okay. All right. Let's look at another example. Okay. So the first thing I'm going to do again is say what the vertex is. Okay. So the x part is this number, but with the opposite sign. So instead of -3, I have +3. Okay. And then here's the y part of the vertex. Okay. So 3, -1. Okay. Now I have that a is 2. Okay. So what this is going to do is multiply the y part by 2. Okay. So let's look at what this graph would look like. Okay. So here's my graph. Three, -1. Okay. Okay. So I'm going to graph my vertex, which is at 3, -1. Okay. And then I'm going to graph my other 2 key points. Okay. So we know that they're on either side, right? One is here and one is here. Okay. So normally they'd be 1 unit away, but because of the 2, they're going to be 2 units away. Okay. So this distance is 2 now. Okay. And it's because of this 2. Okay. And the same thing here. We know it's 1 unit over and 2 units up. Okay. And now I'm going to connect with my parabola shape. Okay. All right. We're going to do some more examples of this. Okay. So let's look at part C. Okay. So my vertex for this is going to be, okay, so remember the x part has the opposite sign, okay, and the y part has the same sign. Okay, now my a value, right, the one that's out in front, is going to be -1, okay? So we know that this is going to flip the graph. Okay. All right, so let's look at what the graph will look like. Okay. Okay, so I'm going to graph my vertex, which was -2, 1. Okay, so -2, 1. Here's my vertex. Okay, now we know the other 2 key points are on either side, one here and one here. Okay, so instead of being up 1 unit because it's flipped, they're going to be down 1 unit. Okay, so now this distance is going to be -1. Okay, and it's because of this -1. Okay, right, you can see this -1 unit away. Okay, and now I'm going to connect them with my parabola shape. Okay. All right. Let's look at another example of this. Last example for this video. Okay. Here we go. Here's D. Okay. So the first thing I'm going to do is say what the vertex is. Okay. So the x part is opposite sign, so positive turns into negative. Okay. Y part, same sign. Okay. Now my a value is -3. Okay. So I know that the negative is going to flip it. Okay, and then I know that the 3 is going to multiply by 3. Okay, so let's see what that does to our graph. Okay, so our vertex was what? -1, -2. Okay, so -1, -2. Okay. Now our other key points are on either side. Okay. So we know that they're flipped upside down, so they're going to be going down, right? And the distance here is going to be 3 times, right? So -1, 2, 3, okay? So this distance now is -3, okay? And it's because of exactly this -3, okay? So we're on the either side, we're going to go down 1, 2, 3, okay? And then we're going to connect it with our parabola shape. Okay. All right. So in summary, when you are looking at the vertex form, right? Okay. HK is the vertex. Okay. And then A gives the vertical distance. Okay. To the other key points. Okay. All right. Let me know if you guys need more practice with that. I would be happy to do some more examples, and I will see you guys.